to lesson 7.5, applying the tangent ratio, where we will learn so, ga, to, and I always do this, and then I should have 9 letters. Forgotten one. So, SOHCAHTOA. You can remember SOHCAHTOA. You can remember the rules for all 3 of your first trigonometric ratios. There's a tangent ratio, that's the T. And then in lesson 7.5, we'll learn the sine ratio, that's your S. And the cosine ratio, that's your C. So today we're just concerned with the tangent. And to find the tangent, we're going to do opposite divided by adjacent. Yes, you figured it out. When we get to 7.6 to find the sine, we're going to take the opposite, divide by hypotenuse, cosine, adjacent, divide by hypotenuse. We'll learn what all of those are, but today you're just going to need TOA. Tangent ratio. Let's review some problems that we should be able to do now from earlier lessons in chapter 7. So for the first one, we want to find the values of x and y. I think we had a problem just like this earlier. So I'm going to say that the y, actually I'm going to do 10, which is the hypotenuse, over y, is going to be equal to y over 6. So what I have here is the hypotenuse over the leg, and that becomes the hypotenuse and the leg. So we have y squared. Yes, we've done this before. You know we've had these numbers before, 60. So y equals 4 times 5 times 3. 4 cancel out. We have 2 radical 15 for y. And if this is 6 and y is 2 radical 15, I don't know if this is a 30, 60, 90. No, it's not a, or 45, 45. I know it's not a 45, 45. But I can use Pythagorean theorem. 6 squared plus x squared is going to equal 2 radical 15 squared. That means 36 plus x squared. 2 squared is 4. Radical 15 times radical 15 is 15. 4 times 15 is 60. I'm going to subtract 36 from both sides. X squared equals, should be able to do it on my head, but after all, it is Christmas Eve, and I'm sitting here making movies for you guys. That's what I thought. It just seemed too easy. So x is going to be the square root of 6 times 4. It's going to come out, and x is going to be equal to 2 radical 6. Let's see if I did that all right. Moment of truth. X is 2 radical 6 and y equals 2 radical 15. I am back in business. A trigonometric ratio. is a ratio of the length of two sides in a right triangle. You will use a trigonometric ratios to find measures of side or acute angles in a right triangle. The ratio of the lengths of the legs in a right triangle is constant for a given measure. This ratio is called the tangent. So basically, to find the tangent, remember I told you you're using TOA. To find the tangent of, let's say, angle A, you are going to take the leg length opposite A, the opposite, and divide it by the leg length adjacent to A. So yes, if you were finding the tangent of angle B, then you would take the opposite side and divide it by the adjacent side. You know which side is the adjacent side because there's no hypotenuse here. It's just opposite and adjacent. We're not using the hypotenuse at all. We will use that in sine and cosine. In the right triangle, A and B are complementary, so you can use the same diagram to find the tangent of A and the tangent of B. Just as we said, the leg adjacent to A is a leg opposite B, and the leg opposite A is adjacent to B. Find the tangent ratio. Now, later on, we're going to need a scientific calculator, and since this Promethean board doesn't have one, I'm going to go ahead and use the online scientific calculator that's available to you for the EOC. But right now, we're looking at angle S. And the side opposite S is 80. And the side adjacent to S has a length of 18. So 80 divided by 18 is 40 divided by 9, which is, when you divide it in a calculator, you can actually do this, 40 divided by 9 is 4.44444444. To find the tangent of R, so I'm going to use the blue one, 18 is opposite R. 80 is adjacent to R. So 9 divided by 40, 9/40, this is your fraction, and this is your decimal. Even on your test for this chapter, you're going to have to do these and give me fraction and the decimal to the 4th decimal place. So 0.2250. I'll just reset it. And let's try some guided practice. So remember, it's TOA. To find the tangent, you do opposite. So for some reason, the sound went out on this portion of the video. I'm not really sure why. You're doing the tangent, the opposite over the adjacent. And if you follow along, I'm going to try and narrate this for you. The opposite is 24. The adjacent is 32. 24 divided by 32 is 0.75. And you would want to add 2 zeros. I'm not sure what I was saying here. And then we're going to do the other tangent. Sorry, the tangent of K. The sound went out when I was recording, so I am trying to record the sound over the video, trying to figure out what I was probably saying at the time. So now we are going to do the other problem. And we're going to do the tangent of J and K. Once again, that's going to be opposite over adjacent. I was obviously talking a lot and moving the pen around. So the opposite of J is 8. The adjacent is 17. That is the fraction. Tangent of J is a fraction. Tangent of K, well, I'm going to fix that in a minute. It's not 8 over 17, it's 8 over 15. I remember making this mistake for the tangent of J. It's going to fix it in a minute. So the tangent of K is 15 over 8. I'm going to go back and fix that original tangent of J. I'm going to divide each of those. 8 divided by 15 is, I can't see that little tiny print because I'm looking at it on like a quarter of the screen. Oh, 0.5333. And the tangent of K, which would be 15 divided by 8, is 1.875. tangent of an acute angle to find a length. This is where we would actually do it. And they're telling us that this is 32 degrees. That means that the tangent of that, the tangent of this 32 degrees, just like they have here, is the opposite over the adjacent. So the opposite is 11, we don't know x. So we have to go ahead and multiply both sides. So you have x, we have here, times tangent 32 equals 11, okay? And now divide back up here. We need our tangent of 32 on the bottom. So you guys are gonna say to me, but how the heck do we know what the tangent of 32 is? Well, in the old days when I was a kid, you had a chart, you had to look it all up. But nowadays, we have the beauty of a calculator. That's not the calculator one. This is a link to the scientific calculator for the EOC. So you're going to do tangent 32 equals, and that it is 0.62486. We're rounding to the 4 places, so 0.6249 is what we're going to use. They've actually already put that in, they figured it out, but that's how they got that number. And then when you take 11 and you divide by 0.6249, you're actually going to get 17.6. So you would actually be able to find out this was about 17. So for some reason, when I'm recording these, the sound keeps cutting out on the recording. So rather than re-recording everything, I just have the video. I'm going to talk over it, and I can record in iMovie the sound. So we had this problem, the length was 17.6. So now we have a lamppost. Find the height of the lamppost to the nearest inch. And I don't know if you can see there, but there's an angle there that's marked as 70 degrees. So we're going to find the tangent of 70 degrees. That's the opposite over the adjacent. The opposite is h. The adjacent is 40. And you're going to say, how did we get the tangent of 40? Hopefully in a moment we're going to, as I did this problem earlier, I can't actually edit any of the video right now. We're going to go to the EOC scientific calculator, but if you're bored, you can type tangent 70 into your scientific calculator. I don't know what I was saying here in the initial recording. So, I go to the EOC calculator, and I'm going to hit clear. I hope I did. Oh, I did. And tangent 70, and it's that number. And then I think what I did is, so that I could remember the number, going back and forth between screens here, I went ahead and put it in the calculator. Moving very slow. These videos always this boring to watch. And then I multiplied it by 40, and I got 109.9. So the lamppost is about 110 inches tall. Now we're going to use a special right triangle to find the tangent of a 60-degree angle. Because all 30, 60, 90-degree triangles are similar, you can simplify your calculations by just choosing one as the length. We're finding the tangent of 60, and every time we need to find the tangent of 60, it's going to be the same number. So x is across from 30, x radical 3 across from 60. 2x is across from 90. So if I put 1 in for x, that's going to be radical 3. And remember, I think we're going to do this in a minute, to find the tangent that's going to be the opposite, which is radical 3 over 1, which is still going to be radical 3. So the tangent of 60 is going to be radical 3. If you put that into the calculator, here we're going to do this. show you. Put radical 3 into the calculator, it's still going to be whatever the square root of 3 is, and that's roughly 1.732. So here we're going to have tangent of 61 is equal to the opposite over the adjacent. Okay, that's going to give me x times the tangent of 61. This is driving me crazy. I don't know why. I record the clips and then the video sound cuts out. So I have to go back in and record over. So what am I doing here? I can't even see. It is like tiny. I'm doing the tangent of 61, but I did that wrong. So I go back in, clear it. Tangent 61 is that number. Went ahead, put it into the calculator. Back to the other screen. I'm going to write the number down so I don't forget it. Wow, the nice thing about these videos is they go by really slowly. So that if you're having a hard time catching up or following along, so 22 divided by 1.8040 is 12.2. That gives me the length of that side. I may have said it at some point in these videos, but eventually we're going to be able to use these numbers. In the next lesson, we're going to learn about sine and cosine ratio so that we can find any missing length we want. So now we want to find x. We have the angle is 56 degrees, so the tangent of 56 is the opposite, which is x, over the adjacent, which is 13. Okay, that means I'm going to multiply 13 by the tangent of 56. So the tangent of 56 is that number. You could just still use that calculator, but I'm switching back and forth so you can follow along. It's that number, 1.4826, rounding. So that number, it's in my calculator, times 13. Is 19 points, that's going to round to 19.3. And that is the correct answer. Number 5. What if, in example 4, suppose the side length of the shorter leg is 5 instead of 1? Show that the tangent of 60 degrees is still equal to radical 3. Remember that the tangent is actually a ratio of two sides. So the side opposite the 30 is 5, which means the side opposite the 60-degree angle is 5 radical 3. I'll do this very slow here because everything on this video is slow. So 5 radical 3, which is the opposite, divided by the adjacent, which is not radical 3. I made a mistake there, but I'm going to fix it. It's 5. So opposite over adjacent, the 5's cancel out, and you get radical 3. Sound keeps going out. So we have a diagram here. So we have a diagram for exercise 1. A, side opposite angle A is 18. Side opposite angle B is 80. Side opposite angle C, which is hypotenuse, is 82. They want me to find the tangent of angle A. So that's tangent of angle A is opposite over adjacent, so 18 over 80. They want it as a fraction. 18 over 80 simplifies to 9 over 40. And when I divide 9 divided by 40, I get 0.225. Okay. And for B, that's going to be 80 over 18, which simplifies to 40 over 9, 4.4444. Now they asked me to find B first, so when I pull this away, they're going to have the information there for the tangent B, and then for tangent A. Doesn't matter which one I did first, just make sure if they're asking you a question, especially on a test, that you put it in the order they asked for it. So, next one, let's say that length of A is 17. This is 31 degrees. Find B. So B, so opposite, 17 over adjacent, B. So B times the tangent of 31 is going to be equal to 17. So B is going to be equal to 17 divided by the tangent of 31. So I'm going to go back to my scientific calculator. And remember what I'm finding here. Move that away. So the tangent of 31, messed that up, I forgot what I put here. So the tangent of 31 is that number. .009. So 17 divided by 6.009 is 28.3. And that's the length. For number 3, now I'm finding B, where the measure of angle B is 74 degrees. So tangent of 74, that's the angle that they gave me, is going to be opposite over adjacent. So I'm going to go back to my other calculator, find the tangent of 74. I can't remember, of course, what I said. So it's the tangent of 74. It's that number. Put it into my calculator. And I'm going to multiply that by 9. And I get 31.4. Okay, last problem here. Last problem here. Find A is 5 and B is 79 degrees. They want us to find the area of the entire triangle. So the tangent of 79 is going to be equal to B opposite over 5. So I'm going to need to multiply 5 by whatever the tangent of 71 is. Which I've done this already. I did it twice because I think I keep saying 71, but it's the tangent of 79. And it's 5.1446 times the 5. So the length of B is about 25.7